Okay, as we continue some of our exploration with geometry, we're going to take a look at some three-dimensional shapes. In the last section or two, we talked about two-dimensional polygons, and we've talked about lines, which is one dimension. So now we're going to take a look at three dimensions. So let's take a look first at what we mean by a simple closed surface. Okay. This has a connected interior, but there's no holes and is hollow. It has no holes and hollow. So think of a Toblerone box, think of a pipe, a box with no ends, a paper towel tube, something like that. Okay, so it's a hollow, no holes. A solid, well, the name kind of helps. A solid is solid. A solid contains the interior points as well. So I'm going to use this a little bit later, but think about a deck of cards. If I have just the box, okay, if I have this box, all right, we have a simple shape. This is actually what's going to be called a polyhedron. It's empty on the inside. If I take all of these cards and I put them inside, these are solid. When they're all stacked together, it makes a solid shape. When I put them inside, this now becomes a solid. So this is now a solid shape, okay? We're going to look at that again in a minute. So here's a term that we will be using a lot, and it's called a polyhedron. Polyhedron. This is a simple closed surface made up of polygons or faces. Now, one thing about a polyhedron is if it's a simple closed surface, it's hollow. It's hollow. So we want to think of an empty box, okay? Think empty box. Because it's got to be hollow. So a polyhedron might be, these are pretty nifty. We're going to be using these several times during the course of the next couple chapters. I don't know if you can see the hollow, empty container. There's nothing in it. But I can see that it's made up of a bunch of faces. I have a square, and then the sides are all rectangles. Okay, so this would be an example of a polyhedra. So think empty box. Okay, so if I draw this, the easiest way, and I'm gonna try to help you here. Let's draw an empty box. I'm going to do the solid front that you would see, the solid side that you would see. These parts, if you have a box, you would not see, so I'm just going to make like a parallelogram out of it. And then I would also then see the front, whoops, so sorry. and the edge. There's the top, but I wouldn't see that back line down the side. And if you can't draw it, it's okay. Okay. That's basically looking at your box where you see the front edge, 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 face. So let's look at some of the vocabulary. Okay. When we look at this line, or these are called the edges. The lines that make up each of those sides are the edges. These corners are what we call a vertex. And then each of the ends, all this solid part, like a square or the rectangle, those are called the faces. Surfaces. So think of it as a surface. It's a face. Okay? And then while we're at it, let's go ahead and talk about the definition of a sphere. A sphere is a set of points, of all points, equidistant from a center. If we go back to a two-dimensional shape, I would be talking about a circle. Those are the set of points that are equidistant. Now I'm talking about a circle going in every direction. Okay, so it's like a ball. Think of a sphere as a tennis ball, a baseball, a soccer ball. So if I want to draw the sphere, the easiest way to draw the sphere is to start with a circle, start with your center, and then make kind of like a little oval for the part that you do see, and then the part that you don't see. And some people stop there. Other people go ahead and do it the other way as well. I don't want too many curves, but you could also do that coming around the other way. Okay? And so that's what we mean by a sphere. And a sphere is not a polyhedron. A sphere is not because it does not have surfaces, it does not have lines, and it does not have polygons. All right? So we talked about a polyhedron. A polyhedron is the empty box. A polyhedron is, I went in the kitchen. Here's a polyhedron. It's just an empty box. Okay, I took all the crackers out. So here's our polyhedron. If this was solid, like a brick, where every single molecule is solid and full, then we don't call it a polyhedron. It now becomes a prism. Okay, so a prism is a solid. It's a solid, three-dimensional, okay, space. It's a solid shape. A shape is probably a better way of saying it. Whose cross-section, if you take a bunch of slices, you're going to get the exact same shape. Okay, so where any cross-section parallel to the base will be a congruent to the base. All right, will be congruent to the base. So to the base. And this is where it's nice to think of a deck of cards. Okay, so as I said, especially when you're working with students, it's hard for them sometimes to understand. So bringing in a loaf of bread helps. Bringing in a deck of cards where if they think of this as a solid shape, where no matter how I slice it, every single slice is exactly the same shape as the base and is parallel to the base. That's what we mean by a prism, where it's the exact same shape all the way through. So again, sometimes a can of Pringles potato chips. Each of the shapes is the same in theory, or our stackable Ritz crackers. I should have brought in one of them because they're all shaped the same and they stack up. Okay. All right. However, that's a prism when it's solid. So you may see here's a rectangular prism. Where in theory now, if I slice each one will be a rectangle if I slice it horizontal. If I slice it vertically, each one would be probably a square. All right? And the base is whatever the shape that is going to reoccur. A right prism means that all the bases are perpendicular to both the top and the bottom. So all the line segments joining the parallel bases are perpendicular to the bases. So here is an example of a right prism, where when you look at this, all right, every single line I draw from the base to the base, if these two are the bases, each one of these would be perpendicular to each base. If I turn it and I use, all right, this square as the base and the other square as the base, every single time I cut it, I'm going to get lines that are absolutely perpendicular. So that's called a right prism. Same thing would happen if I have a triangular base. No matter how I slice it, these are at a right angle, they're perpendicular to each other. So I have a whole bunch of them. These are all right prisms because no matter how I slice it, each of these lines is perpendicular to both bases. And remember, the base is the shape that it maintains as you slice through it. So if I just kept slicing this, I would get a bunch of hexagons. All right, so that's what we mean by a prism. A prism is a solid. Now, we also have something that's called an oblique prism. You're going to love the definition. An oblique prism is not right. It's a prism which is not right. Sounds kind of funny. Think Leaning Tower of Pisa, where instead of having, let's see if I can draw one. Instead of having, here's a right prism, okay? Kind of like the red one I drew here a minute ago, where it's standing absolutely vertical and it's at a right angle to the base. If it is suddenly leaning over, then it is not a right prism. Let's see if I can do this one. Okay, So it's as if somebody's pushed it over. Whoops, I lost a side over here. 1, 2, 3. Yeah, so it's not pushed over. So think Leaning Tower of Pisa. That's a good example of something that is not right. Now a prism keeps its shape and maintains its shape no matter how I slice it, like a loaf of bread. Okay. The deck of cards. Now let's think about what's called a pyramid. And a pyramid is a polyhedron, so it can be hollow, or it can be a prism that's solid, okay? Or solid, rather. It can be a polyhedron, so it can be hollow or solid. Which has, think of it as, it comes to a point. It has an apex. And that apex is not on the base. Pyramid, anything that comes to a point. So it could be, here's a pyramid with a square base. I don't know if you can tell, so I'll hold it this way. So the base is square. But you'll notice that it comes up here to a point. That point is called the apex. Here's another pyramid. Notice the base is a triangle this time, but it comes up to an apex. So that's a pyramid. It can either be solid or it can be hollow. If it's hollow, it's called a polyhedra. So here's a way to draw one. Let's say we draw this one, a pyramid with a square base. Easiest way to draw it is draw the square first. There's your base. Draw the apex. It's not a vertex here, it's called an apex. That's not sitting on the bottom, not sitting on the base. And now connect that apex to all 4 corners. And you've now got a right pyramid as long as this is at a height. You may have seen this in geometry. Oftentimes you'd have the picture here and they would show you the height at a right angle. That would mean it's a right pyramid. Okay? And you can do this with any of the shapes. We could have a cone. A cone actually has a circular base. But it has the circular base, but it's not solid all the way through. Instead, it comes to a point. All right, so I could have a circular base. I could have a point not on that base. And then we don't have corners this time, so we just sort of go out to the edges. All right, so I think you get the right idea. And you may have this height we actually call the altitude. The altitude. And the altitude is always perpendicular to the base. So now that we have an idea of a polyhedra being hollow and prism is solid where you can slice it and they always end up being the same, let's take a look at something that's called a truncated polyhedron. If something is truncated, it's been shortened, it's been stopped. So if I want to take a look at a truncated polyhedra, And one thing I did include is you may find in that module, you may find that I did give examples of polyhedrons. So instead of trying to draw them, or if homework or lab problems refer to them, you might take a look and you can see some of the most common polyhedron. Okay, so you will find that in the module for section 11.4. Now, a truncated polyhedron is a polyhedron where one or more of the corners has been removed. One way to think of it is imagine you have a birthday cake. All right, so maybe you've made this sheet cake, and you know you've got this sheet cake, and it's got happy birthday or whatever the occasion is. Right now, it's a solid. Right now, it's a prism because no matter how I cut it, if I keep slicing all the way through, I'm going to end up with the same shape as one of the bases. Or I could slice it horizontally and get a lot of rectangles. But imagine you come along and you decide you want to cut off part of this cake. So you decide you want to cut off this wedge right here. Okay, so imagine you cut that piece off. Well, if I cut that piece off, it is now, okay, if I cut that off, it's now missing this piece. And so what ends up happening is it's been truncated. Part of it's been cut off. So it's now not the exact same shape as I go all the way through it. So the easiest way, in my opinion, to kind of think about what a truncated would look like is imagine you have a pyramid. Like, let's do a pyramid. And I told you before, come up here. Here's a pyramid. And imagine somebody comes along and they slice off the top of that pyramid. So if I come along and I slice off the top of that pyramid and I decide to cut the tip off, it doesn't come to a point anymore. It now has this rectangular piece that's been cut out of it. Okay? And so that's what we mean by a truncated polyhedron. Okay, so now that we have an idea of a polyhedron is hollow, a solid is solid, everything's in between. Let's take a look at the regular polyhedra that are out there. And what's nice is we have a finite number of them. All right, so let's take a look at the definition of a regular polyhedra. Polyhedra is just the plural of polyhedron. Okay, so we only have 5 of them. And again, those 5 regular ones, I've listed the 5 regular ones on this reference page. I gave you some other ones that are kind of fun, just so you can see. But we only have 5 regular polyhedra. A regular polyhedra would be a polyhedron whose faces are regular polygon regions. And if you remember, if something is regular, it says that all the angles are the same, all the sides are the same. So I was thinking I had one, but I don't think I do. So we have a few of them, okay? We have a triangular, a tetrahedron. A tetrahedron is 4 triangles. But before I do that, let's start with a cube. Your basic cube. If I start with a square, and I extend this the exact same distance so that each of these surfaces is also a square, any sort of cube, I have one in here. I do, but I'll just grab the blue one. A cube is a regular polyhedra because every single one of the 6 sides is the same shape. Every edge is the same, every angle is the same, so therefore it's regular. This has 6 squares. Okay. We also have a tetrahedron. Okay. A tetrahedron is made up of 4 triangles. It's a little trickier to draw. So if I have a base that's a triangle, and each one of these edges is also a triangle. Okay? So it's got 4 triangles. I'm not going to try to draw the other ones. I'll just tell you what they are. And I have included them in our handout that's in the module. We have an octahedron, which has 8 sides, and they're all triangles. We have a dodecahedron. Okay, this one has 12 faces to it. Okay. And those faces are all pentagons. And we have the icosahedron. And that has 20 faces, which are all triangular. So the good news is there's only 5 of these, all right? And I will not ask you to draw some of those because they get very, very, very tricky. So there's only 5. All right, now let's say you're trying to help students create or build a polyhedra, all right? If we're going to build one, if we're going to try to analyze the shape, and we'll look at this again later on when we look at surface areas, but you might hear of a term called a net. And a net is a pattern. A net is a pattern. It's a pattern used to construct a polyhedra. printed out a net of what it looks like on paper. This might be what a net of a cube looks like. And what you can see is on this piece of paper, we have a square base, and then each of these edges, each of these lines would represent where you would fold it. Now they've included little tabs so that you could actually cut them out and tape them together. But you'll notice we have a square. We have a square. We have a square. And each of these shapes represents each of the faces of this polyhedra. And since all of them are the same, it's regular, therefore it's called the cube. I also happen to have one. If I take this shape that I showed you before, and I take this prism, and I open it up, my finger just got stuck in there. Sure works better when it comes out smoothly. Welcome to teaching, right? And just when you think it's going to work smoothly, it doesn't. Ah. Goodness. Okay, got it. This is what's called a net. Right? And this is still a cube, it's just designed a little differently. But you'll notice each of these fold lines are the edges. And you'll notice I still have 1, 2, 3, 4, 5, 6 squares, such that when I fold up these two sides and I wrap this around, it creates a cube. Now if it's, so that's called a net, and it helps you and it helps your students learn all the various shapes. So this will come in very handy when we start talking about surface areas later on. Okay, but it's pretty cool. So there it is, that's a net. So I have a net for each one of the shapes that we were talking about earlier. And the idea is you just cut and fold, and that would help you come up with your polyhedron. All right, and the last couple things we'll look at, kind of did already, we touched about it, is what we mean now when I have a polyhedra, remember, is based on a polygon, many-sided figure. Well, what if I don't have sides? Then we start looking at cylinders and cones. A cylinder. Okay. A cylinder is not a polyhedron. Because a cylinder does not have edges. A cylinder is not made up of polygons. A cylinder is made up of a circular base. So a cylinder, a right cylinder, here's a right cylinder, it's got a circular base, it's got a circular top, and kind of like a soda can is a cylinder. It's a right cylinder, of course, if each of these bases is perpendicular to each other. So if that altitude is a right angle, that altitude is perpendicular to both of those bases, then this would be a right cylinder. Okay. If I take and I push this cylinder over, now this is not right, so this would be considered an oblique cylinder. Okay. And then, so this is still a prism, Keep in mind, this is still a prism, because no matter how I slice it, I still get circles, like the stack of Ritz crackers, okay? Now, if this circular base comes to an apex, comes to a point, I cannot call it a pyramid because it's not made up of faces that are polygons. I would have to call it a cone. Okay, so a cone has a circular base, and it also has an apex. So a cone, if I start with a circular base, I start with an apex. There's my cone. Okay. So it still looks like a pyramid in the fact that it comes to a point, but it has a special name since the circle is not a polygon. And of course, we could have a right circular cone, which means that this altitude is at a right angle with the base. So here's a right cone, or a right circular cone. But of course, I could also have one that is not right. So one that is not at a right angle to the base, and so this would be oblique. All right, so hopefully that helps everybody get started and looks at their geometric shapes. If you want to see more examples of nets, we'll be looking at them a little bit later. But a net is pretty fascinating, and it's a great tool to show students where and how the shapes, where they come from and what they're made up of. Okay, so that wraps up chapter 11, and then we'll be continuing with other aspects of geometry for the remaining chapters.